Alright, we should be able to finish up our intensity lab now. And if you didn't get the data or something, we can just get it right now. Here's the distances that we copied down, and then the current, which is measuring our intensity of the light, but it's in milliamps. We've got the name up top. We've got it again on the spreadsheet. Just get in the habit of putting that in there. The name is for your name. And then if you don't have the data, just copy that data. We need to graph it. So we go down to insert chart, and hopefully you've done this much of it because we did this together. We're just going to get a scatter plot. I'm actually not going to keep it for now, but I just want to use it to look at this. Whenever we see a curve like this where we've got our intensity on the top, distance on the bottom, we know there's a relationship between the two that's inversely related. We should have a line going this way, right? But instead we have it going that way. So we're trying to get a linear slope out of that, but we don't have it. So we're going to have to manipulate that data. Let's get rid of that. We know it's inversely related. And so what we can do is we can just take the inverse of the distance. So I'm going to type that here, 1 over the distance. That means our units would be 1 over meters. I can get the program to do the calculation for me. I start with equals, and then I just type. I want 1 over, and then A4 is the number that I am taking inverse of. And then again, I can get it to do all the calculations if I just go over to the crosshairs in the corner, pull it down. Now we've got all our data. We've got this problem though with this spreadsheet that our current needs to be on the other side of our distance in order to graph the right way. So I'm just going to copy that, paste it over there so that the distance is on the left because we want that on the x-axis. So I can grab the data, go back to insert a chart again. But this time we should see a different shape, right? And we want a scatter plot again, so we'll select that. Again, I'm not even going to keep this one because it's just not going to be the right thing. But in this case, we can see it's better, it's positive, but it's still not a straight line. There is a curve to it. And so whenever we see that curve, we think, oh, it's exponential. Most likely it's a squared relationship. And so if I can square the x values, those distances, then I should be able to get the right look on that. Still have distance or 1 over the distance on the bottom, still have the current on the side, but we need to get the squared value of 1 over distance because of that slope, because it's not a straight line. So let's do that. I can take 1 over the distance squared. I'm just going to note that so I know what I'm talking about. That means the units is going to be 1 over meters squared, which gets a little cumbersome, but that's okay. And again, now I just want to calculate the values in that C column. So I'm just going to say, okay, equals this number, right, squared, because this is already 1 over. So I can say, all right, equals C4, and then caret 2, we'll square that. And then I want to do all of them, so I just do the same thing. Get the crosshairs in the corner, drag it down. Now I've got the 1 over distance squared. Again, current's on the wrong side, so I can just grab the current column, copy and paste it so that it is on the right side, because that means it'll be on the y-axis. Grab those values and insert a chart one more time. Get my scatter plot. Even though the dots are more spread out, it is a straight line. That's what I'm looking for. And so now I'm gonna go through the process of actually labeling it, getting everything else on there. I should title it. Technically now this is 1 over the distance squared versus the current. So I'm going to label that. So I'm knowing, saying what I know it is. It's not just distance anymore. It's not 1 over distance anymore. It's 1 over distance squared. And again, the current represents the intensity. Label my axes. So on the horizontal side, again, 1 over distance squared. 1 over distance squared. And my units are 1 over meters squared. And then that should show up down below. I can switch it to vertical just by clicking that. Go down. I've got intensity on the side, but again it was current, so current is measured in milliamps, so I'm going to put those things on the side. And then really what we're after, right, is that equation. Sometimes this has physical significance, sometimes it just helps us understand things. So I'm going to go grab that linear fit, and then I can scroll down again to label it as a line. Even though the points aren't all on there, it's the best fit we're going to get, so I'm going to go get that use equation. And that just shows up in the right hand corner there. Now we're finally good to go. I hit insert, I've got a graph. Typically in a lab you would include all the graphs, but since this is just the first time we're working through this is what I'd like you to submit. If you could resize the graph so that you can see the equation, the graph, and all the data in one look. That would be great. And then you can submit it to Schoology and just drop it in the folder on there.